So hello everyone, let us solve today's GfG problem of the day, and the problem name is Alien Dictionary. So let us read the problem statement first. So given a sorted dictionary of an alien language having n words and k starting alphabets of standard dictionary, we need to find the order of characters in the alien language. Now also they have given some additional note that many orders may be possible for a particular test case, and thus we may return any particular order and the output will be 1. That means the string returned is correct, otherwise it would be 0, denoting that it is an incorrect string that we have returned. So let us see this first example and try to understand what the question is saying and derive some solution out of it. So let us see this first example. So this is the first example that they have given, and what the question is saying that there is some language known as alien language. Now we have some language known as English language. Similarly, they have defined their own language. They are naming it as alien language. So we have English language and they have defined alien language. They are saying that there is one dictionary in this alien language. We name it as alien dictionary, and that alien dictionary follows some particular order. Now in English language also we have one English dictionary which follows some particular order of all the alphabets, like we have A, B, C, D and so on up till Z. So this is the order in the English dictionary, that A is coming before B, B is coming before C, C is coming before D and so on and so forth. So this is the particular order which English dictionary follows. Similarly, we need to find out the order in the alien dictionary based on the given words that they have given. So we need to figure out this order. So let us understand how we can figure out this order in English dictionary first. Then based on that we can apply the similar approach here in the alien language as well, and then we can find out the order in the alien dictionary. So first let us figure out how this order is being formed in English dictionary. So let us see that first. So let's say I have been provided with two words which are in sorted order AAB and AAC. So AAB is coming before AAC. So this is the first one, this is the second one. These are in sorted order. So how we can say that this AAB is lesser than AAC? So we need to find some point of difference by which we can say that AAB is smaller than AAC. So let us find out that point of difference. So first we have these two characters A and A. So these two characters are same. That means we can't compare them because they both are same. So this is not the point of difference. So we go on to the next two characters. Again they are both A and A. So this is again not the point of our difference. So we come across to the next two characters. The next two characters are B and C. So yeah, these both are different characters. So we can say that yeah, this is the point of our difference. Now I have previously said that AAB is lesser than AAC in the sorted format, and here B and C is differentiating factor. So can't we say indirectly that B is less than C, or B should be coming before C in our English dictionary? Yes, we can say that. Otherwise, how we can say that this is the sorted format? So in this particular test case that we have taken for AAB and AAC, we can say that B is coming before C. So this is one particular order we can figure out from this from these two words. So this is the order which we are talking about, that B is coming before C. Now let us come out to the alien language for this test case. So let us now find out the dictionary order for the alien language that they have given, and we will use this similar approach. We will try to find the differentiating factor, and according to that we will find out the dictionary order in this alien language. So let us run this try for this test case first. So they have given BAA, ABCD, ABCA, CAB and CAD. Now how we will compare the words? Now again they have said that this is in sorted format. So what we can do, we can compare two pairs of characters. So first we will compare these two, BAA and ABCD. Then we will compare ABCD and ABCA. Then we will compare ABCA and CAB, and then we can compare CAB and CAD. So this is the pattern which we will follow by comparing two characters. So let us first compare BAA and ABCD. So yeah. So let us find out the point of difference in these two words. So first we will be standing here. So we see that yes, the first two characters are different. So B and A are different. And we are saying that BAA is smaller than ABCD. So we can say that B should be coming before A. So from comparing the first two words, that is BAA and ABCD, we figured it out that B should be coming before A in our alien dictionary. So now let us come to the next two words. So now the next two words which we will use is ABCD and ABCA. ABCD, it is ABCA. So yeah, let us start from the beginning. So here we have A and A, so both are same, so this can't be the point of difference. Then we come to B and B, again this can't be the point of difference. Similarly we have C and C, both are same, this can't be the point of difference. Then we come across D and A. So you see that these two characters are different. So we can say that yes, this is the point of difference in these two words. So again, this is in sorted format. ABCD is coming before ABCA. So we can say that D should be coming before A in our alien dictionary. So what we can say, D should be coming before A in our alien dictionary. So from this comparing these two words, we figure out D should be coming before A. So let us now move on to the next two words to find out the next relevant order for our alien dictionary. So the next two words are A, B, C, A and C, A, B. So let us compare the first two characters, A and C. So A, B, C, A is less than C, A, B. And this is the point of our difference because these two characters are different. So we can say that A is less than C in our alien dictionary. So what we can say, A should be coming before C in our alien dictionary. So we can say that yes, A should be coming before C. So from comparing these two words, we figured it out that A should be coming before C. So let us move on to the last two words for our comparison, that is CAB and CAD. So let us do the comparison. CAB, CA and D. So these two characters are same, this can't be the point of difference. Again A and A can't be the point of difference. Then we come across B and D. So you can see that B and D are different characters, so this can be the point of difference, and we can say that B should be coming before D in our alien dictionary. So B should be coming before D, that means B should be before D. So B should be pointing to D in our alien dictionary. So we have compared all the pairs of words in our given test case, and what we can figure out that what we can find the order of the alphabets is that B should be coming before A. Okay, B should be coming before A should be coming before C, and D should be coming before A. So we can generate one such string of order of the alphabet. Now let us see if this follows this particular order or not. We say that B is coming before D. So yeah, B is coming before D. D should be before A. Yes, D should be before A. A should be before C. A should be before C. And here we are saying that B should be before A. So yeah, B is before A. So yeah, we can say that B, D, A, C is one such valid order of alphabet in the alien dictionary, and we can return this string. Now how we can find out this particular order? Now if you see that, see this carefully, the diagram which I have drawn, I have intentionally drawn in this way by making these arrows and all that, because we can say that this is some kind of graph, a directed graph. So we can say that this is directed graph because we are following some direction. B is pointing to A is pointing to C, D is pointing to A, and B is pointing to D. So this is for sure a directed graph. Now there is something special about this directed graph, that this is not only directed but it is also acyclic. What does that acyclic means? Acyclic means that a graph should not contain any cycle. Now if you see that B is pointing to A is pointing to C. So till now we don't have any cycle. B is pointing to D, D is pointing to A, and A is pointing to C. Again, we reached out to a particular point C. That means we don't have any cycle in this graph. So we can say that this is directed acyclic graph, or you can simply say this is a DAG. Now, have we done something before like this? Like we have studied something related to directed acyclic graph and ordering of elements. Now whenever we need to find some order of elements, and we figure out that the graph which has been provided to us is directed acyclic graph, we can use a topological sort to find out the order of elements. So we will use this topological sorting algorithm to find out the order of elements. Now what order of elements? We have discussed that B, D, A, C was one valid order of elements for this particular test case. So similarly, by using topological sort, we can figure out the valid order of elements in our alien dictionary. So why we are using topological sort? Because we need to find some ordering of elements, and topological sorting is only valid in directed acyclic graph. And by our observation, we figured out that yes, this is a kind of directed acyclic graph. So yes, we can apply topological sort. Now in this question, we are not going to discuss topological sort in very much detail. I'll make some video for that in some other lecture, but we'll not go in much detail for the topological sort. Yeah, we will obviously discuss the topological sorting section, but not in much detail. So let us see how our algorithm will work and how we can apply the topological sort to get the ordering of the elements. So let us discuss the flow of our algorithm. So first of all, what we need to do? We need to create a graph, or we can say we need to create an adjacency list. So first we need to create an adjacency list. Now how will we create the adjacency list? We have already seen in the dry run of this example test case. We will take two words from this given language, and we will figure out the point of difference. For example, in this test case, the point of difference was B and A. How did we figure out the point of difference? Whenever let's say this is string A, not string A, sorry. Let us name this as string S1. Let us name this string S2. So whenever S1 of I is not equal to S2 of J, that means this is the particular not S2 of J, S2 of I only. So whenever s1 of I is not equal to s2 of I, we can say that this particular I is the point of difference. So we can store these two characters, not characters, we need to store it in integer format. So what we can do, here we have been given that k is equal to 4. That means there will be 4 distinct alphabet A, B, C and D. So what we can do, we can name A as 0, we can name B as 1, we can name C as 2 and we can name D as 3. So what we can do, we can make an adjacency list, and what we can store, in front of 1 we will push back 0. Now this 1 will represent B and this 0 will represent A, similar to what we have seen in the dry run of our example test case. So this is how we will create our adjacency list. So this was the first step, and what we will do, we will then apply the topological sort algorithm to find out the order of the alphabets. For that we will write one function which will do the topological sort and give us the valid order of the alphabets. Now after that, what we need to do, now the returned answer of this topological sort would be in some like integer format. As we have seen, we will name this into integer format, but in the end we need to return the answer in string. So no problem, whatever order which we have got from this topological sort, let us say we got something like 0 to 1 3, 0 to 1 3. Let us say this is the order we got from the topological sort. So now we need to again convert it into alphabet and then we need to return that. So no problem, 0 means A, 2 means C, 1 means B and 3 means D. So we are not taking this for this example. I am just generally saying that this is what we will do. So we'll convert it into respective characters and then we will return. So in the end, what we need to do, we need to convert that into integer to character and then return the resultant string for our final answer. So this will be the flow of our algorithm. First we will make adjacency list, and then for that adjacency list we will find out the we will apply the topological sort and find out the valid order. And after figuring out the valid order will be in the integer format. We will convert it into character, and that after that we will convert it into string, and that string we will return. So let us see the code now and understand in more better way how we can apply this algorithm into our answer. So let us see the code now. So I have already written the code and we will understand this code line by line, and this is similar to the algorithm what we have discussed in the example test case. So let us see the code now. So first we need to create an adjacency list. So we have defined an adjacency list of size k because we can have k distinct alphabets. So how will we create the adjacency list? We have discussed, we will compare the two words, two pair of words. Let's say we have string A of dict of I and string B of dict of I plus 1. So in the first example we have seen that this was BAA and ABCD. So this is what string A and string B are representing. Now we need to find out the point of difference in these two strings. So how can we figure out the point of difference? So whenever A of J is not equal to B of J, so in this example BAA and ABCD, this first B was not equal to this first A. So this was the point of difference. So we can say that B should be coming before A. So this is what we have done. So we have pushed back in the corresponding adjacency list of alphabets. Now we don't have to store it in the alphabetical form. So what we have done, we have subtracted this character A from both the ends, and this will convert this particular alphabet into integer number. For example, B to 1, A to 0 and so on and so forth. and then we will break out because we already find the point of difference, so there is no further point on moving ahead in this string. So this will go on till we find out it for all the possible pairs, and after doing this for all the possible pairs we will get our adjacency list. Now after the adjacency list, what we have seen, we need to apply topological sort algorithm. So we have this solve function that will be applying the topological sort algorithm, and which will give us one valid order of alphabets. So let us see this solve function, or the in which we will apply the topological sort. So what is the basis of topological algorithm or topological sort algorithm? So it works on the basis of the in degrees. So what we do is we try to remove one particular node from the given graph and see what all difference it will create to the in degree. So first we will take out the node which has the in degree of 0, and we'll try to remove that particular node from our graph, and we will see what effect does it create to the rest all nodes which are connected to it. So this was the basic idea behind the topological sort algorithm. Now we will see line by line how this topological sort is working. So first we will find out the in degree of all the elements or all the nodes in our graph. So this is the for loop which will find out the in degrees. After that we will make a queue, like we have discussed that we will start with the node which has the in degree as 0. So whenever we find that this particular node has in degree as 0, we'll push it into our queue. Now why we are pushing it into our queue? Now whenever we have the in degree as 0, then that means that this would be the first element of our topological sort that we will get in our final answer. So we pushed it into our queue, and now what we will do, we will take this particular node out of the queue and we will try to remove this particular node from our graph, and we will see what all changes it is making in our graph. Now what do I mean by what all changes? Now if we remove that particular node from our graph, it will change the in degrees of the adjacent elements which are connected to it. So we will try to decrease the in degree of its adjacent elements. So let us see in more better way what I am saying. So we have declared one answer which will store the topological sorted order of the alphabets or integers, you can say anything. So we will apply it until our queue becomes empty. So first, initially all the elements whose in degree is 0, we have pushed it into our queue. Then we are like popping it out from our queue, all the elements whose in degree is 0 one by one. Now we are pushing it into our answer. So in degree 0 means this will be the order, this alphabet will be pushed into our answer in the relevant order which we have till now. So element having the in degree 0 will be pushed into our answer. Now what we have seen that we need to go to its adjacent elements and remove its in degree, because we have seen that in topological sort we try to remove that element from the graph and see what all changes it does. So what all changes it does, it gets disconnected to its adjacent elements. So what does that mean? We need to decrease the in degree of its adjacent element. So we go to the adjacent elements. So for that we are using that for loop, and we decrease the in degree by 1 because we are removing one node. So we decrease the in degree of its neighboring elements by 1. Now if that neighboring element in degree is 0, then again we will push it into our queue. This would be the element that would be in our order which we are trying to find out whenever it turn comes in our queue. So this will keep on happening until our queue becomes empty, and in the end this answer is giving us the valid alphabetical order based on our topological sort algorithm. So after getting the topological sort format or the order, what you have seen, this will be in the integer format. We need to now convert it into character so that we can return it in the string format. So what we can do, we can create a string result which will be giving us the order, like dictionary order of the alphabets. So what we can do, we can iterate on to this vector of int answer, and each integer we will now convert it into corresponding character. So for that we can write something like this: character of it plus a. So if it was 0, it will convert it into a. If it was 1, it will convert it into b, and so on and so forth. We are keep on adding it to our string result. In the end, we will return this final resultant string, which will be the alphabetical order in our alien dictionary. So this is how this algorithm is working. So let us try to submit if it is getting accepted or not. So let us see now. So yeah, our code got successfully accepted. So hope you learned from this video. Thank you.